With zero and negative exponents, things start to get a little bit tricky, but as with everything else in math, there's an internal consistency. Now, when you first learned exponents, and when I first explained exponents, I explained it as shorthand notation for repeated multiplication. This explanation breaks down when we start to talk about a zero exponent or a negative exponent. And I'm sure in the history of math, positive exponents were used pretty much exclusively for quite a long time. The laws were developed, and then along came zero exponents and negative exponents. And we have to have an interpretation for these in order to keep the rules consistent. So one way to look at this is just to say, well, what's happening with this pattern? 2 cubed, for instance, is 2 times 2 times 2, which is 8. 2 squared is 2 times 2, which is 4. 2 to the power 1 means you just take 1, 2, so it's just 2. Now, you can see as we go down the list that we're just simply dividing by 2 or multiplying by half, whichever way you want to think about it. If I continue that pattern and divide 2 by 2, I get 1. If I continue that again, I get a half, and then a quarter, and then an eighth. And this is indeed the values that we assign to 2 to the power 0, 2 to the power negative 1, etc. Now, there's another way to justify this, and it has to do with the laws that we've already developed. Let's say, for instance, we had a division. So 2 to the power of 2, for instance, divided by 2 to the power of 4. Well, using our law for division, we can just say, well, this is simply 2 to the power of 2 minus 4, which is 2 to the power of negative 2. But we know what this means because we know what 2 to the power 2 and 2 to the power 4 are. We can rewrite 2 to the power 2 as simply 2 times 2, which is 4. 2 to the power 4 is 2 times 2, which is 4, times 2 again, which is 8, times 2 again, which is 16. Now, 4 over 16 is a fairly straightforward fraction that can be simplified as 1/4. And so there we have justification again that 2 to the power negative 2 has to equal a quarter, otherwise the laws that we've already developed don't make any sense. Similarly, a zero exponent can be justified because anytime you have the same thing on the top and bottom, let's say 5 to the power 7 over 5 to the power 7, if we use our law for division, we would have 5 to the power of 7 minus 7, which is 5 to the power 0. Well, anything divided by itself is always going to be 1, and therefore anything with a zero exponent is always 1. So that's our first law there. Now there is one exception to this, and that is if the base is 0. You will very rarely see a base of 0. 0 to the power of anything is just 0, so there's no real point in using exponents with 0, but that is one exception. And how can we write a law for a negative exponent? Well, notice the pattern here. 2 to the power 1 and 2 to the power negative 1 are simply reciprocals of one another. So remember, a reciprocal just means to flip it. If you have an integer, you just write it as 1 over the integer. So 2 and 1 over 2. Similarly, 2 to the power of 2 is just simply 1 over 2 to the power negative 2, or vice versa. So you have 4 and 1 over 4. 2 to the power 3 is 8. 2 to the power negative 3 is the reciprocal of 8, 1 over 8. And we can write this as a law. b to the power of negative m is just simply 1 over b to the power of positive m. And when you have to simplify an expression that has negative exponents, this is one of the first options that you might want to consider. Anytime you see a negative exponent, just simply rewrite it as the reciprocal, the same base, but a positive exponent. So let's try a few examples down here. Negative 8 to the power of 0. The base is negative 8. Doesn't matter as long as it's not 0. Anything to the power of 0 is 1. Now, the second one, negative 3 to the power of 0. This is a bit of a trick question, because remember, what is the 0 exponent acting on? It's only acting on the 3. So we have 3 to the power 0, which is 1, and then we've got that negative sign stuck in front of it. Because of order of operations, this actually becomes negative 3 to the power 0, which is negative 1. Be very, very careful if you come across something like this. Alright, let's take a look at a couple examples with negative exponents. 5 to the power negative 2. Right away you can write that as 1 over 5 to the power of positive 2. And if you want, you can just expand 5 to the power of 2 and write that as 1/25. 2 to the power of negative 4, immediately you can write it as 1 over 2 to the power of positive 4. Or, again, you can expand the 2 to the power of 4 and write that as 1 over 16. So 2 to the power of positive 4 is 16. 2 to the power of negative 4 is 1 over 16.